Hello everyone, Aaron here and welcome back to Leetcode. Today we're doing the longest palindromic substring problem. I'm on holiday at the moment, so this one's been pre-recorded, but I'm sure I'll be back soon enough. Right, short and sweet description. Given a string S, return the longest palindromic substring in S. So here, BABAD, we've either got BAB or ABA. BABA is not a palindrome. Remember, a palindrome has to be read the same backwards and forwards, so BABA, although very similar to ABAB, is not the same. Right, how do we want to go about this one? I think this one is going to be a variant of a dynamic programming algorithm. A pretty simple dynamic programming algorithm. Words. If the picture I have in my head at the moment is correct of how I think this will work. So, what have I got in my head? Basically, I want to make a table, which is, well, it's a very simple table. It's just a list, the same length as the string. And it says, well, what's the longest palindrome that starts at this, or that, say, ends at this character? So, initially we can say they're all 1. Or at least we can say this is 1, and the rest are undefined. If I go to the A, either it extends this palindrome. So if we go B and we extend it to have an A, we need to check back on the other side of the B and make sure it also has an A. It doesn't, so this is just length 1. We can then go to the B here. We can say, well, this could extend the A. This was palindrome length 1. We could extend it. That would require an A on the other side, a B on the other side, and lo and behold, we have that. So this is actually a length 3 palindrome. We want to go look at the A here. We want to see, well, hang on, could we extend this palindrome to be a 3 palindrome? This 3 palindrome? That require an A over here. Ugh, we can't do that. What we can do is say, well, hang on, what if we didn't use this full palindrome? Ooh, actually, that's a bit of a weird case, isn't it? What if we didn't use this palindrome? How much? No. If we can't extend the full palindrome, the best we can do is just revert back to a 1 palindrome, isn't it? Yeah. So then we would see that ABA does work. So this would be a 3. This would also be a 3. The D, we would want to see if this thing is preceded by a D. It's not. It's preceded by a B. So that one can't be extended. And then we can revert back and say, well, at least, does this thing before it contain a D? No. So I think that is the algorithm. So what we've got here is the length is going to be 1 times len s for I, in fact, no, let's do I, C in, actually, how do we want to handle this one? I guess the other trick is that if it's equal to its predecessor, then that's a 2. Anyway, for I, C in enumerate S, prevlen is equal to lengths I minus 1. In fact, what we want to do here is effectively if I equals 0, continue. No, let's not handle that special case. No, let's handle that special case. Right. So, let that motorbike go past. I'm so close to moving off a main road, and I am so keen for it. Right. What was I saying? A. We're looking at A. The previous thing was length 1. So what I want to do is do this minus the length of the previous palindrome minus 1. J is equal to I minus prev len minus 1. If J is less than 0, what I want to do is I basically want to no palindrome extension. Then the options become. We'll come back to it. Basically, why is that offset? Something has gone wrong here in my. Is that where I'm meant to be? I don't know what's gone wrong with the indentation here. The editor has gotten off by 1. Weirdness. If Sj is equal to C, length C is equal to prev len plus 2. In fact, no, we want to do. I need to change how this is done. If J is greater than or equal to 0 and Sj is equal to C, length I, not C, I, is equal to prev len plus 2. That's because we've extended this palindrome by 1 in either direction. Else, well, then we need to change what we're doing. So there are 2 cases here that we need to worry about. If J is equal to more motorbikes? No, J is not equal to more motorbikes. J is equal to this character minus 2. I minus 2. If J is greater than or equal to 0 and Sj is equal to C, length I is equal to 3. Else J equals I minus 1. If J is greater than or equal to 0 and Sj is equal to C. Well, what I really should do is refactor this, but we'll hang on. Length I is equal to 2. Else. Pass. Give up. There is nothing else to do. Right, so all of these are basically the same. So what we actually want here is J's is equal to I minus prev len minus 1, I minus 2, and I minus 1. Those are the options on how we can build a palindrome. So it's for J in J's. Then I want to do this logic. It's not prev len plus 2, it's I minus J plus 1. Break. Let's just start there and see what we get for lengths. For here, I expect to see 1, 1, 3, 3, 1, for example. 1, 1, 3, 3, 1. Good. 1, 1, 2, 1. Is that what we expect? 1, 1, 2, 1. Perfect. That is what we expect. So now what I need to do is take this and turn that into the longest palindromic substring. And the way I do that is I find the maximum one of these, or I find the index of the maximum one of these, and then take that many characters back. So J is equal to the max of the enumeration of lengths. Key is lambda v v1. I want the maximum of the values, not of the indices, but I actually want to get the index. No, what do I want to do here? I want j length to be those two things. I is j minus... hang on. Let's call this index. So now I want to take the s from the index minus the length through to the index plus 1, I think. Let's test that. The indexing here is a little bit complicated. No, I need to see the index and the length, I think, to fully understand what's going on here. Zero, 1, 2. 2 minus... Oof. Loud motorbikes, they are everywhere tonight. So I want to do index minus length plus 1 through to index plus 1, because this is length 3, because it goes 0, 1, 2. There we go. Just gotta get my indexing in the right order. Right, I don't need that anymore. Let's run it again. Yes, these are still passing. We're getting both of them right. Now the question is there a way of making a palindrome that I have not handled? This is extending the palindrome. This is making an odd length palindrome. And this is making an even length palindrome. I don't think there's any other ways of making a palindrome, but we'll find out. Wrong answer. Okay. What did I not handle here? One, two, three. Why did this... Okay, this didn't increase to a 4. And that's because it couldn't extend this palindrome by adding another thing here. Ah, this is weird. This is weird. Because there's sort of 2 palindromes for this one. So obviously this one here it's saying here's a 3 palindrome, which is correct. There is a 3 palindrome there, but there's a sneaky 2 palindrome inside it, which is much, much harder to find. And this is only valid for the palindromes that are all one character. This is an edge case. And very specifically, it's an edge case that's quite hard to find. Because if this was A, B, A, A, I need to make sure I'm not accidentally going to trip A, B, A, A. Maybe I don't want to store the maximum palindrome at a particular location. I want to store all palindromes at a particular location. So what I want is here, prev lens. Oh, I didn't need that J line anyway. It's going to be... Well, we're still going to handle this case where they match, but the rest of them are an artifact of I minus L plus 1. Is that correct? I just got rid of it and I've forgotten what it said. I minus L minus 1. For L in prev lens. So what does that look like? In object is not... Oh. Oops. So we've got 1, 1. Which test is this? It's not really telling me. Let's turn this off for now. Let's just fail the test by not returning anything. At least we continue that. So we see in this test, all the palindromes here are of length 1. All the palindromes here are of length 1. There's a length 1 palindrome here, but there's also a length 3 palindrome here. Same with this one here. There's a length 1 and there's a length 3 palindrome. And here there's just a length 1 palindrome. With the next one, there's a length 1 palindrome, there's a length 1 palindrome, there's a length 1 and a length 2 palindrome, and there's a length 1 palindrome. And in our special test case with 4 A's, we see there's a length 1, a 1, 2, a 1, 2, 3, and a 1, 2, 3, 4. That's what we want. Oops. That was the indentation for that. So I think I want max lengths. Oops. No, I still want lengths here. No. I want max length. Yeah, a length 3, a length 2, and a length 4. So this needs to have a max length on it. Yeah. Nice. That's nasty. Very nasty. Right. Let us submit again. See what other test cases we missed. Oh, nope, that looks like it worked perfectly. Excellent. We are nowhere near a good solution by the look of it, but again, this is probably not, well, yeah, there looks like there's a long tail and bit of a hump that we're near. No idea what's going on with our memory. We're apparently using lots and lots of memory. I suspect we probably don't need to maintain every length, but I am. I'm maintaining every length. Anyway, this was a little more tricky than my gut instinct said it was going to be, because I had forgotten the case where all the characters could be the same, which makes my palindromes a lot more subtle to try and detect. But we got there in the end. So, do let me know how you did it. Did you manage to claw up this runtime, or down the runtime and down in the memory? I'd very much be interested. I would be very interested in hearing how you did that. Anyway, do let me know in the comments. Remember to like, comment, subscribe, all of that good stuff, and I'll be back from holiday soon. I will see you next time. Bye.